Okay, we're going to look at going from standard to vertex form without, though, completing the square, because completing the square is the most common way to do this, and it's kind of complex, so we're going to use a little formula instead. We have our two forms here. The first form is the standard form of a quadratic equation, and this is the vertex. And normally, or the vertex form, sorry, and normally we complete the square to go from standard to vertex, but we're going to do it without completing the square. And what I'm showing you here, this is the quadratic formula. So the quadratic formula is normally to take standard form to a factored form, or to at least find the x-intercepts. So this essentially tells you what your x-intercepts are. Okay. But there's a little part of this formula that's actually very helpful. It helps us find the axis of symmetry from standard form. Okay, and the part of the formula, it's going to look like this. So I want you to think of the axis of symmetry. Okay, and normally, or a lot of times I'll write it as AOS, okay, is from standard form negative b divided by 2a. Okay, and this little formula actually tells you exactly where the axis of symmetry is going to be. So this little part of the formula is actually the front of the quadratic formula. And I can explain how we got this idea. I want you to think of, if you're doing the quadratic formula, if you guys think of fraction rules. So fraction rules, for instance, if we have x plus 2 over 3, something like that, okay? Or, actually, since that's a more difficult concept, if we have maybe 5 plus 2 over 3. This can actually be split into 5 over 3 plus 2 over 3. Okay? So in other words, we can use that denominator and put it to the bottom of both sides. So since we have a plus and a minus sign here, we're going to split our quadratic formula. So this is where we get this idea from. X is equal to negative b over 2a, and then plus or minus the square root of, b squared minus 4ac, again all divided by 2a. Okay? And the idea of this is this part here is your axis of symmetry, okay? And this is your variation from the axis of symmetry, this part here, okay? Which makes sense, right? Because our x-intercepts are always going to be equal distances from the axis of symmetry, so this variation, say the number was 5, it's telling you to get the axis of symmetry and add 5 to it and subtract 5 from it, and that'll give you your two x-intercepts. So, more importantly though, since we've derived that equation, we can use this equation to find the axis of symmetry. So let's say we have a standard form equation, something like this. F at x is equal to 5x squared plus maybe 15, no, let's go with 110x minus 30, something like this. Okay? These are our a, our b, and our c values. Okay? We're going to plug that into that little formula for the axis of symmetry. We're going to take our negative b divided by 2a. So, in that case, our axis of symmetry is going to be negative 110 divided by 2 times our a value, which is 5. Okay? So that means our axis of symmetry is actually going to be negative 110 over 10, which is going to give us negative 11. So our axis of symmetry is at negative 11. Well, the good thing about the axis of symmetry is it's actually also the x value of the vertex. Okay? So, is the x value of the vertex, like we were saying. So, in this case, the x value of the vertex is negative 11. And since we already have the x value of the vertex, we can plug that back into the standard form equation. Okay? So let's do precisely that. We're now looking for f at negative 11, and the formula was 5, and then our x squared, so negative 11 squared, plus 110 times negative 11. I think it was minus 30. Minus 30. Okay? So we'll put this into our calculator and kind of solve this all in one step. Let's take a look here. So we have 5 multiplied by bracket negative 11, okay, squared plus 110 times bracket negative 11, and then minus 30. Negative 635. Okay, so pretty big value. Negative 635. Okay, but that's important because that is the y value of our vertex. Okay, and that's where the y value would be. So now that we have those two coordinates, okay, if you recall our vertex form, f at x is equal to a, which we showed at the beginning again, x minus h squared plus k. Well, the actual coordinate of the vertex in this case, which is negative 11 and negative 635, okay, our h value is our negative 11 and our k value is our 635, so we can plug them in. The other good thing about that is from standard form, the a value is always the same as our vertex form. So we know that the a is going to be the number 5. So all we needed to do was plug our information into this little formula, get our x value of the vertex, and then plug that back into the standard form, and then we can plug our vertex into our standard form. So our vertex becomes, our vertex form is 5x, and now it's minus negative 11, so it's the idea of plus 11 when it comes in, squared, and then our k value is minus 635. Okay, so we've just changed standard to vertex form without actually having to complete the square.